Hello, I'm Gabbie. I work as a project manager and I'm also a member of the WISE Young Professionals Board. And today I'm going to be interviewing Dr. Lauren Hobbs, who is a scientist working on high power lasers in California. And we're going to be talking about nuclear fusion. So, my first question, what is nuclear fusion?
So, fusion is what happens in the sun. It's what turns clumps of gas and dust out there in the universe into stars and galaxies and ultimately us. The visible universe is made up mostly of hydrogen, the first element in the periodic table, with a single proton and electron. As gravity works on these clumps of gas, they begin to collapse inwards, reaching temperatures and pressures high enough to strip the electron from its proton. The positively charged protons can then be squeezed together, and if the force is enough to overcome the repulsion you get when you bring two particles of the same charge together, they can fuse to form helium, the second element on the periodic table. So, during this process, scientists found that the mass of the resultant helium is a little bit less than the mass of the hydrogen that went into it. This extra mass is released as energy, and as we all know, E equals mc squared. Now, the mass is tiny, but this is happening on such a large scale that it releases a tremendous amount of energy into the star.
And why is this process so important?
So that explains why fusion is important in the universe. But closer to home, scientists have been trying for many decades to create sustained nuclear fusion here on Earth. If possible, it would mean a safe, clean, and practically inexhaustible source of energy.
So, we fuse light particles together and we get nuclear energy. Why is it so difficult to achieve practically?
Absolutely. So the difficulty lies in overcoming the repulsion between the two positively charged particles for long enough to allow for fusion. First, the hydrogen needs to be heated to create a plasma, stripping the electron away from the nucleus in the middle. This takes energy that has to be supplied up front in order to start the reaction. Then we need to bring the nuclei close enough together to fuse.
And how are we trying to achieve this on Earth?
There are many different methods being explored to create fusion here on Earth. As a laser scientist, I'll be talking about inertial confinement fusion. So in inertial confinement fusion, or ICF, we rely on a laser hitting into a pellet containing the hydrogen, heating it, and then squeezing it together until it fuses. Using the National Ignition Facility, which is the world's most energetic laser, they achieved what scientists across the world have been working towards for many decades. They fused hydrogen, releasing more energy than was put in with the lasers. Now, the National Ignition Facility is big, really big. It's 10 stories high and could fit 3 football pitches inside it. And it's not just one laser, it's actually 192. So how it worked was, instead of having all of these laser beams hitting into the pellet of hydrogen directly, scientists found another clever trick. They used these tiny cans, about 11 millimeters high and 6 millimeters wide. By using these cans, they create a kind of oven that heats the hydrogen and squeezes it together at the same time. By doing this, they were able to reach temperatures of over 180 million degrees Celsius, which is in fact even hotter than the center of the sun.
Wow, so it sounds like a lot of research has already gone into this. So, what will happen next in this field and why is it a great time to get involved?
Absolutely. So the focus now for scientists all across the world, from public to private labs, universities and governments, is to make those advances in science and engineering that are needed to create a fusion power plant, where we can create continuous fusion reactions, generating a constant source of electricity. In the coming decades, we will need more and more scientists and engineers working on this problem. In the UK, a prototype power plant called the Spherical Tokamak for Energy Production, or STEP, is being developed to demonstrate the use of fusion to generate energy. So being a scientist working on the use of high power lasers, I get to see firsthand their potential for not only fusion, but solving the puzzles of what we see happening across the universe. I would recommend science to anyone who has the curiosity that when they come across something you don't understand, you can't help but want to learn more.
Sounds like a really fascinating and rewarding career path with lots of opportunities available. Thank you so much for your time today, Lauren.